Hello, welcome to this video. Today I will show you how to analyze bone cavities with the Imalytics Preclinical software. Here we have a micro-CT scan of a piece of cortical bone, and it has these cavities here, which are resorption spaces. And let's have a look at other orientations here. You can rotate it, and you can see that they have a kind of matchstick shape here. And in this analyze we are going to skeletonize this cavity and compute the cross-sectional area orthogonal to the path here, and also the largest fitting sphere inside as a statistic readout. So let's start by segmenting the cavity, and we can do this using thresholding and region growing. So let's pick a threshold. You can see the intensity is down here in the corner. So the intensity inside is 0 and outside something like 200. So let's use a threshold 100 and create a temp class and threshold everything below 100. Now we have all these dark things here, and here you can see this cavity. And let's create a class cavity, and to do a region growing operation. So we have the cavity and delete the temp class. So now you can see here the cavity, and you can see this matchstick shape, and we need to get rid of this piece here. So let's jump there and use a slice where we are orthogonal and do a cutting here and here with F2. Now it is separated here, and now we can set the output class to unclassified and do a fill region operation to get rid of that. So now here we have the cavity nicely cleaned up. So now let's perform the skeletonization. So we set the input class as cavity here and select bone, single bone skeletonization of input class, and save this as an Excel sheet here. It says skeleton has been computed, path is shown, please use undo segmentation to restore the input class. This means here you can see the path, you can dilate it by 1. Now you can see it better. That is the path that has been computed as a skeleton, and you can use the undo segmentation operation to get back. The path is also stored in the CSV file. So let's open the CSV file, that is this one here, and here you can see lots of columns, and the first column here is the position along the principal direction in millimeters. So the software computes the direction in 3D, the principal component direction of this segmentation, and then computes the cross-sectional area orthogonal to that principal direction. That is here, and we can compute a plot with Excel here like this, and you can see the area in square millimeters along the class. You can see here here it gets thicker, there's a larger area. And you can, if you shift this here, you can see the sphere radius. It's a similar readout, but it's in millimeter. It's the largest fitting sphere inside the cavity. Let me explain what that is. So let's compute a distance map inside the input class here and go through. Now you can see here as an overlay, you can see the distance map. Let's hide the segmentation, and this shows the values of the largest fitting sphere contained in the input class. And we can, to test if this works accurately, you can load an existing segmentation here from bone cavity, and here we have two other segmentations, a perfect cylinder and a kind of matchstick shape, and you can measure the diameter of the cylinder here in millimeters and compute the known radius, or you can even generate a new cylinder here with create region and then compute the statistics for the cylinder and check if the results are correct. This is what I did here in this figure here, and these are the three segmentations. And here you can see the cross-sectional area along the principal direction, and in blue we have this matchstick thing here, the yellow one, and here from the cylinder, and here from the cavity. And we have the same using the for the distance map values, which represent the largest sphere radius that fit at each slice. Okay, I hope this helps. Thank you and bye bye.